Alright, so for number 1, you just have to describe how the a, h, and k affect the function, the parent function. So a, what it does is it vertically stretches or compresses by factor of a. And then the h translates, so it just slides it over left or right, and then the k translates up or down, and that's all you had to say for that one. Alright, so number 2, the b value is 2, and so that means that you are going to multiply all the x's by a half. The y's stay the same. Okay, so right here, -4, 3, you're going to multiply the -4 by 1/2, so 1/2 of -4 is -2, so -2, 3. 0, 3 stays there, because 0 times a half is 0. 4, -2 becomes 2, -2. And 6, 0 becomes 3, 0, because we're cutting all the x's in half. And so you just connect the points. And, oops, not too straight, but there it is. For number 3, I've underlined it in 3 different colors for each of the parameters. So the first one in yellow, vertical stretch by a factor of 5. So that's your a value, so that goes in the front. And then in red, translated 3 units to the right. So remember, right, you do the opposite, so you're going to put x minus 3. And it's a square, it's a parabola. And then in purple, 2 units up, that's your k value, so you just do what it says. Up 2 is plus 2, and that's it. So number 4 has a vertical stretch by a factor of 4, so that means a is 4, but there's already a 2 there. So 4 times 2 is 8. And then shifting to the right 1 unit, that just means translating to the right 1 unit. So you're going to put x minus 1 squared, and then there's no shift up or down or translation, so you just put plus 5. So that's the answer right there. So number 5, you have to circle in each row. You have to circle the transformation that's going on here for f of x. So first thing we see is that we have an a value, and so that means it's vertical, and because it's less than 1, we know that it's a compression, so it's vertically compressed. And then this -8 right here, it's a k value, so it's going to be translated down because it's k, not h, and that's it. So for 6, we have to choose the ones that apply to this function. So horizontal stretching or compressing, no, because the b value is 1. But there is a horizontal translation right here, so that's this one. There is a vertical translation right here. And there is a vertical stretch right here. And then the negative right here gives you a reflection over the x-axis. To show algebraically whether a function is even, odd, or neither, you replace all the x's with negative x, and if you get the original function back, it's even. If you get the opposite of the original function back, it's an odd function. And if it's neither one, it's not completely the same or opposite, then it's neither. So this one, number 7, is neither, because this is not the opposite and this is not equal to the original either. Number 8, you have an even function if its graph is symmetric with respect to the y-axis, like I wrote right here. So this one is not symmetric with respect to the y. And then it's odd if it's symmetric with respect to the origin. Well, that would mean that if I hold here and I flip 180 degrees, this function, it'll go right over itself, and it doesn't. So it's not odd either. So this one would be neither. So for number 9, we have this answer true or false to each of the 4 questions or statements. If a function has a -1 as its x-intercept, then its inverse has -1 as its y-intercept. So the function would have the point -1, 0, and the inverse would have the point 0, -1. So we could see here clearly that the two numbers switch, so this is true. For B, to find the inverse of a function, replace f of x with x, and this is where it falls apart because we don't replace it with x, we replace it with y. The graph of the function and the inverse function are reflected across the line y equals x, yes. And then if a function is 1 to 1, then its inverse is also a function, and that's also true. It has to be 1 to 1 in order for its inverse to be a function. So for number 10, the relationship between the domain and the range and its inverse, the function and its inverse, is that they switch. So if the function has this as a domain and this as a range, then the inverse has the first one as a range and the second as a domain. So they switch places. They switch from domain to range and from range to domain. So they switch. 11, what must be true about a function for its inverse to also be a function? It has to be 1 to 1. So it has to be 1 to 1. 1 to 1. And if it's a graph, how you can tell, it has to pass the horizontal line test. Okay? So number 12, the first thing you do is you switch out the h of x with y. Then in step 2, you solve for x. So first thing we're going to do is multiply by 7. Because we multiply by 7, so the 7's cancel on the right side. So now we're going to subtract 6. Divide by 2. And so now that x is by itself, we switch the x's and the x and the y. And then step number 4, we change the notation of y to to function notation. Oops. That would be the answer for that. So number 13, step 1 is we switch out the h of x with y. Now we're going to solve for x for step 2, so we add 6 to both sides. So since we added 6 to both sides, it's no longer on the right side, right? And so I'm going to get rid of the -1/5 by multiplying by -5. Remember, it's over 1, so it cancels here. So x is -5y minus 30. You distribute the -5 here and here. Switch the x and the y. And then switch out the notation. And this is it. Okay, so 14 has 4 transformations. There's a -3. The negative reflects the graph over the x-axis. The 3 is a vertical stretch by a factor of 3. The 1 translates the graph 1 unit to the right, and the 3 translates the graph 3 units up. Alright, so for 15, you have your reference points right here. For a quadratic, these are the reference points. This +1, it means that h is negative. That h is -1, so you're going to subtract 1 from x. This +2 means that k is +2, so you're going to add 2 to y. So negative 1 minus 1 is negative 2. 1 plus 2 is 3. Then negative 0 minus 1 is negative 1. 0 plus 2 is 2. Then 1 minus 1 is 0. 1 plus 2 is 3. So now we're going to plot those points. Negative 2, 3. Negative 1, 2. And 0, 3. So there's your parabola. Okay, so for number 16, it's a cubic function. These are the reference points right here. These are the three main ones, and then this one we just throw in to make sure that we don't confuse it with a cube root function. So now we're going to do the transformation. So it's going to be negative 1 minus 2, so that's negative 3. Negative 1 plus 3, that's positive 2. 0 minus 2, and then 0 plus 3. 1 minus 2, and then 1 plus 3. And then 2 minus 2, and 8 plus 3. Okay. Remember, this is the inflection point right here. So that's at the point at which the curve switches direction. So now we're going to plot negative 3, 2, negative 2, 3, negative 1, 4, and then 0, 11 is like way up here. So that's all. You just need to know the direction that the graph is going in, so you know that this is going to go curving like this and curving down like that. And so remember, this is the inflection point. So for number 17, the power function is basically the leading term of the function. So we look at all the x's, so there are 3 of them, and the coefficients are all positive. So you end up with x cubed. Okay? And so this is, it says as x goes to negative infinity and as x goes to infinity. So negative infinity on the left, the function goes down, and on the right, the function goes up. Okay, the x-intercepts, you look at the factors and you ask yourself, what makes them 0. So negative 1 for the first one, 2, 0 for the second one, and 6, 0 for the third one. The multiplicity for each one is odd because the powers up here are all 1, and 1 is an odd number. And so now we're going to graph this. So negative 1, 0, 2, 0, and 6, 0. Now I know it didn't ask you for the y-intercept, but you can just quickly replace the x's with 0, and you get, here you get 1 times negative 2 times negative 6 is positive 12. Okay, so now I know that the end behavior is down up, and it's going to cross through each of these 3 zeros. So my graph is going to go cross like this. And this point right here would be 12. Okay? Now to get the exact value down here and the exact value of how high it goes, you need a graphing calculator. Okay, but for us this is enough. So number 18, it's asking you how many times, determine the number of times that the graph crosses and the number of times that the graph is tangent at the x-axis. So we look at the first 0, its multiplicity is 1, and the second 0, its multiplicity is also 1, so it crosses 2 times. Specifically at 0, 0 and 7, 0. Now you look at the third 0, its multiplicity is even, it's 2, so it's tangent 1 time at 3, 0. So for 19, we want to show that both sides, both compositions equal x. So the left one is f of f inverse of x, so that means that we're going to take this function and put it in place of that x right there. Okay? So I'm going to take and then I'm going to simplify. So